Welcome to SF Commercial Property Conversations with Bruce Bean, where Bay Area investments meet expert insights. Get ready to unlock the strategies of commercial real estate success.
So today we have David Ellner with us, and David graduated in engineering from Stony Brook University in Upper State New York, right?
This would be on Long Island, Eastern Long
Oh,
Island.
Long Island. Okay. And that's where you were born also.
New Hyde Park, New York. Yep.
Nice.
Nassau County.
And so you then transitioned out to the West Coast and began you worked at your engineering career from there. So give us a little explanation of what you do, which is very intriguing to me.
Well, I'm on the tail end of my career here, and I've been consistent for the last 45 years, engineering, building technology systems in large buildings, high rise, low rise, doesn't matter, upwards of 1 million square feet. And these days, after a long career of engineering, my favorite role is to work for building owners who require their physical plant, mechanical, electrical controls, HVAC systems to be modernized. After 25, 30 years or so, these systems get old. It's oftentimes very challenging to integrate new technologies to replace the old technologies, and just navigating a project from due diligence through construction and commissioning. And so I stick with it from beginning to end, acting as owner rep, project manager, commissioning agent, and anything else in between to assure that the project proceeds on time, on schedule, and is ultimately a success.
Well, so given a building that's, say, 35 years old, I mean, technology has changed, technology and engineering has changed drastically. I assume that you can save these buildings a substantial amount of money by getting new systems put in and so forth, and the electricity and heat and so forth is a much lower use than previously.
Yes, energy efficiency, sustainability is a very strong driver these days. Owners want it. You've got the Energy Star program, you've got the LEED, LEED program, and those programs are still very active. And so it is a priority for owners, and we can use the savings that we get from improved efficiency to help justify some of the costs of these projects. You've got two kinds of mechanical modernization. You have the voluntary type, which is pretty much just driven by energy efficiency, and then you have the mandatory type that your systems are just so old, they're not functioning well anymore, and they need to be replaced. So we can aggregate the benefits and achieve the objectives.
So I assume on a big building, million square feet, you can't really install solar panels, but I'm sure you can do a bunch of other things to reduce the energy of that building.
Yeah. Just the way the mechanical systems are configured, the equipment is selected, the controls are installed and programmed, and then the operating engineer who lives with this day in and day out needs to be trained and understand, and that's how you get the best out of it. Throw in some good sub-metering and measured diagnostics, which you get from some of these good control systems these days, and you can assure that the efficiency will be sustained over time.
Is AI starting to jump into this whole category?
Yes, it is. I have been kind of fiddling with it in my head, at least, for many, many years, saying this is what we need. This is what we need, and it is starting to happen. I've not yet seen real practical applications of it, but we're hopeful to see it soon.
So would the AI actually analyze the building and be able to come up with recommendations, or what do you think is going to happen?
It could play out in a number of different ways. Yes, AI integrated with control systems, looking at electrical demand, real time, looking at various temperatures of zones, knowing what various measures and demand reduction strategies can achieve. Having that all done automatically, with some historical insight by monitoring hundreds of points historically, using that data to help train an AI assistant for controls. That's kind of one way I'd see it. Yeah.
So give us a clue of maybe a current project that you're working on that kind of is maybe not integrating AI, but give us an example of what's going on there.
Well, one project I'm working on here in Newport Beach, California. It's a older building, maybe mid 60s construction. It's a medical office building, pushing 100,000 square feet, fully occupied with doctors and patients in and out all day long. We've got a chiller plant on the roof, boiler plant on the roof. We've got air handlers on every floor, old controls, and it all needs to be replaced because
Oh
it's
God.
60, 70 years, and it's got to be replaced basically without, it's got to be invisible.
Right, right. One day you walk in,
They can't tell tenants that they can't use the space. They got to have air conditioning. So you've got a real challenge to construct this system during the evening hours, during the weekends, and during the day when you can. We struggle with noise. It's very close to a residential community, so it's
wow.
like you can't win. If you make noise on the penthouse, you're disrupting the neighbors at night. You can't do the work during the day because then you're disrupting the tenants. It's just an interesting, fun challenge. And this is prototypical of the type of projects I work on regularly. And you got to be available to be there to help solve problems that might come up real time. So that is kind of a typical one.
So I'm curious on that particular project, do you install the whole system and then take out the old system?
No, you've got a mechanical room on every floor. In that
Oh,
mechanical room is a single air handling unit that provides all the heating and cooling for the entire floor. And you've got to, over a long weekend,
yeah.
shut it off at 6 p.m. on Friday. You got to demolish the old air handling unit. You got to install the new one, and I don't mean just bring it in because these buildings are oftentimes landlocked. So you got to have these air handling units dismantled in
Oh
pieces. You
God.
bring them up a service elevator. Down a hallway, through a narrow door. So oftentimes you got to enlarge the door, and you got to do all that and have it up and running by Monday morning at 6 a.m.
Yeah, no problem, right?
No problem.
Wow. That is a lot. And this is like I don't know what the tonnage is, but a big machine.
Well, yeah, these would be typical, 15, 20,000 square foot floor plate. It might have 40 to 60 tons of cooling, air handling unit with
Wow.
maybe 25,000 cubic feet per minute of air movement, that kind of thing. And I will say, though, that, there are a lot of very excellent mechanical contractors out there. And they know how to do this work, and they're geared for and set up to do these long weekend work.
Wow. And all that equipment can go through a man door?
Well, that's why you got to dismantle it.
Oh. Yeah.
It can either come in cubes that'll barely fit in a elevator machine room. Depending on the width and the height of the door, you might have to open it up a little bit, take the door out, and or if it's too large, you fully dismantle it. Each section of that cube would be depanelized and bring it through the elevator, and then put it all back together again in the mechanical room.
I assume that the manufacturers are well aware of this problem and
Yes, they
they
are.
and they
Yes, they are.
design it such that it can be taken apart and put back together.
Yes, they are. And they have factory representatives who are on site over those weekends, oftentimes if requested. It's literally these things come with instructions like an erector set. The pieces are numbered, the bolts are counted, and everything gets put together just like that.
So you get down to the end of the project and you got a couple extra bolts left. You're like, uh-oh.
Uh-oh. Yeah.
Oh my gosh. Wow. Well, this is truly engineering at its best, right? Because this
Yeah.
is a very complex problem.
Yes. Yeah. And
Yeah.
the engineers kind of tell you what the end product needs to look like. They
Right.
tell you which equipment to use and how it gets connected. But the engineers rarely are deeply involved in the how. They'll tell you the what we need done, but the how to do it and how to plan it and organize it and roll it out over a weekend. That's pretty much up to the contractors. They know what they have to do, and in I oftentimes prepare design build RFPs, requests for proposal, to get competitive bidding on this work, or we'll do the engineering and inject that into the request for proposal. But those RFPs that I write, include all the ground rules and the guidelines for when they can do the work, how much noise they can make, when they can make that noise, disruption to tenants, all that stuff. And they have to bring cranes in oftentimes to get the
Oh
equipment,
yeah.
particularly on the roof. And structural sometimes has to be done in advance. So there's all that, but they know the ground rules, they know what they need to do, and they get it done.
So do you end up spending the weekend with them, or hopefully you've done your job and you don't have to be there?
I try to avoid being out there on the weekends. I'm always available if something comes up, but when we're at that on that level, after we've done all the planning, because I'm on it full time up until to make sure everything is planned and so that everything is going to work like a Swiss watch. And by that point in time, there's really not much I can do if things go wrong. Uh,
Right.
I generally try to avoid it. Kind of gives me the heebie-jeebies.
Oh yeah. No, I would think that would be crazy times. So I assume your whole success is to make these projects go smoothly.
That's correct. That's what I do. I make it go smoothly. Again, it's sort of a hybrid role because I am an engineer and I am in the weeds. I've been in the weeds my entire career. I understand what these systems are, what they need to do. I can go in and observe and figure out what the needs are, and I can manage it as a construction manager. I can give the owner the proper advice that they need. I care about it, and so I'm always available. And I know what it looks like when it gets done correctly or not. And am able to then I at the end I'll do the testing and take it through its various sequence of operational paces, which is a complex activity all by itself, just to make sure that the design intent and the performance is achieved.
So give me a clue for the listeners here, for the owners that happen to have a very large building. What is the best piece of advice you can give them in terms of what they typically miss in this process?
Well, they lean on the engineers, large engineering firms. They're going to pick a large engineering firm for a large building. Okay, if you're looking at a 5, 10, $15 million modernization project, you're going to pick a
Big
high-end firm, and they're good. They'll do the job, but they also make mistakes, and they don't always. The communication between engineer and owner, there's oftentimes valuable information lost in translation. So again, I jump in the middle of all that because I can talk to both sides of the table and make those translations and again sit on the engineer, review their plans. Errors and omissions is an important thing.
uh,
When it comes to like the cost of my services, you can save the cost of my services in one change order avoided, and just like that,
yeah, right, right.
and these days there is not. I'll say there's not a glut of mechanical, electrical engineering talent out there.
Right.
So which means you got to be even more careful, and there are more risks associated with it. Did I answer your question, or am I
Yeah,
halfway?
no, absolutely. I think what you're saying in one way is that a lot of owners go directly to the engineers without having a facilitator like yourself, an owner's
Right,
rep.
right,
That has its own problems. So the
right,
advantage you bring to the whole table is that you have the expertise on both sides
right,
and
exactly.
can help them facilitate the whole
Yeah.
process.
I would also avoid putting too much responsibility on the chief engineer
Uh,
for administering this kind of project. This is not what they do day in and day out for a living. So there are risks of missing out on issues, as well as it takes them away from their day-to-day job, which is always
right,
very
right.
important and urgent. And I found this little niche which works really well. There are not a lot of consultants who have the scar tissue that I have, and are kind of able to pull it off, if you know what I mean.
No, I absolutely. I've, observed and been in construction for many, many years and completely understand exactly what you're saying in terms of if well, even if you have a regular construction project going on, it's always great to have an owner's rep on your side. So uh,
Yeah,
it,
and that it speaks the language.
yeah, exactly. It's very
But
critical.
another important thing we've been seeing these days, I think you asked where some of this is going into the future.
Yeah.
Uh, Buildings, a lot of, again, larger buildings, they have large rooftop package units. That's been a mainstay of mechanical systems, or self-contained, 50 to 150 ton rooftop package units that have their own fan systems and dampers and refrigeration and heating, all self-contained. Buildings like that have gone up forever, and there's
Yeah.
hundreds of thousands of them out there. And these days, with the new refrigerants
Uh,
and the energy efficiency codes, these systems and equipment are frequently larger footprint, heavier weight, and taller than the replacement. It used to be you could
oh,
just go to Train or Carrier or York or McQuay or any number of manufacturers and pull a like for like replacement off the
yeah.
shelf.
Right.
But these days you can't, and particularly in California with our earthquake and structural code requirements, the replacement of units that are larger and heavier require structural analysis
Oh, wow.
and oftentimes special accommodations, possibly even having to strengthen the structure, enlarge the pads that they sit on. The height also becomes an issue because these units sometimes also tend to be taller. The codes are very strict with regard to line of sight architecturally, so that people on the street or in other buildings nearby don't see ugly mechanical systems sticking up. So you
Right,
need
right.
architectural enclosures so these existing systems might have architectural enclosure. If you go higher than that, you got to be concerned about it and do a line of sight study sometimes. So there's so it's a much more involved process as opposed to just hiring a mechanical contractor, replace this old one with a new identical one. That sort of doesn't work much anymore.
Is there a trend, certainly in residential, I'm sure, but in commercial office buildings, is there a trend to going to smaller packages that are more distributed throughout the building?
Well, that kind of takes you into a different area. You have a building that was designed originally, maybe it's a 40-year-old building. It was designed originally for some type of system, and to retrofit that 40 years later,
Doesn't work.
you can use the same mechanical concept, which makes some sense, or you can change it. You've asked the question. Yeah, there's technologies where you can distribute the systems out there. There's a one in particular called variable refrigerant flow systems, where you've got refrigeration piping distributed throughout a building, and there's sort of fan coil units also distributed. Those tend to be more challenging for a variety of reasons. You have to also look closer at the electrical distribution, because now you need power in more locations in a distributed sense,
Oh, right,
as
right.
opposed to central. You've got structural issues. I try, if we're looking at a major modernization, I try to configure or synthesize a replacement system that kind of more or less fits into the existing infrastructure framework, as opposed
Right.
to a major technology change out.
You're
So
right.
and we can do that. We could redo the piping, take old inefficient piping strategies, and use new highly efficient piping strategies. We can put way more efficient chillers or refrigeration systems, and of course the intelligence and the controls. So and likewise, if you've got package equipment, you generally makes more sense to make that fit in, as opposed to trying to replace a building born with package systems into a central plant kind of thing. And there are hybrid opportunities that solve both problems, that make sense, that some contractors are doing.
So I'm curious if you don't necessarily actually specify the equipment, you only specify, say, the load or the tonnage or whatever the need is.
Well, throughout my career, I ran an MEP engineering firm. So yes,
Yeah.
I was for many years in charge of producing engineering plans and specifications, multidiscipline, mechanical, electrical, plumbing, structural controls, and that. Since the early 2008, when I left the company, I have been gradually doing less and less what we call engineer of record work. So I generally won't do that. I'm skilled in it. I've done load calcs for 45 years and engineering for
Right.
30, 40 years. So I'm, it's in my genetics, but I'm trying to, as I slide down that mountain toward retirement, I'm wanting to kind of take on less of the heavy lifting, if you will, and more of the this type of scope that I was describing: owner rep, project manager, construction manager, commissioning agent type of role.
You don't want to be the stamp on the plans.
I don't want to be the stamp on the plan. I don't want to have my head buried on one particular design for too long. I like the diversity of it, and the challenges, and my clients love me. I've never advertised for work. It's always come to me either through referrals or repeat clients. So I sort of avoid all of that.
Well, I assume that over the last 45 years, the whole CAD industry has completely revolutionized the way plans are done and so
Oh
forth.
yeah, yes, yeah, and still to this date, there's lots of great design tools, visualization tools. You could bring a camera in and take a panoramic view, excuse me, of a mechanical room, and plunk it into your computer and get a 3D rendering
Wow.
of what's going on there. That's to scale. Engineers who used to have to go on site several times to take those dimensions now generally might not have to go more than once or twice when they are using these kinds of tools, and then these three dimensionals will be then transferred to CAD or other platforms that are used these days.
Well, it's a fascinating world. I think we could talk for another couple days about this whole area. So
Sure.
maybe we'll reconvene down the road here because everything seems to be moving very quickly in terms of the AI situation. So it'd be interesting to
Yes.
see how that develops on the engineering side.
Right. Great.
Well, I greatly appreciate it. Where can people get a hold of you, David?
Well, they can call me on my cell phone at area code 714-925-9224. or email me at, I think you have it there, David at ellnerconsulting.com, ELLN as in Nancy, ER, consulting, all one word.com. That's how you reach me.
That's fantastic. Well, let's stay in touch. This has been very intriguing, interesting, and educational for me. So I think the audience is going to enjoy it also.
Great. Well, thank you, Bruce, for having me on your show. Very much appreciated. And I'd be happy to join you again. We could talk about energy efficiency or sub-metering or, any of the things that are going on these days or, further along on this type of discussion.
We've got topics we can go on for days about. This is
That's
great.
right. That's
All right.
right.
Well,
Okay.
fantastic.
That's a wrap on today's journey through the SF commercial real estate scene. Ready to share your story? Visit sfcommercialconversations.com/guest. Your insights could lead the next conversation.